In this video, we're going to look at integrals of trigonometric functions. The last couple of videos we've dealt with just general functions involving U substitution and so forth. In this case, some of the ideas are going to be the same, except the integrand function is going to involve trigonometric functions. Now I have here the main setup that you're going to look for. Especially when you do a substitution, you would have the integral, something like this. F will be a function of g of x, and then somewhere in the integrand you have a product of the derivative of g. Not always, but those will be the most obvious ones that you'll be able to easily solve. So in this case you have g prime dx. So the obvious substitution would be to let u equal to g of x. Then if you take the differential of both sides, you'll get du equal to g prime dx. So this right here can be replaced by du, and the g of x will be replaced by u. And now you got hopefully a simpler function to integrate. And then those you should know, or there should be a table that you can go to depending on what your instructor tells you. Now, just as a reminder, I have here some basic formulas for derivatives. You see here some that we might use in this video. The sine derivative of sine. U is cosine u, and then times the derivative of u. So there you know the integral then. You know that the integral then of this cosine with respect to u is going to be sine u. Going back the other way, derivative of cosine u will be minus sine u times the derivative of u. Therefore you know the integral, of course, of sine u would be, translate the minus over here, minus cosine u. And then over here in the integrals, we know the integral of secant squared u du is tangent u. The integral of secant u tangent u du is secant u plus a constant. Okay. So let's look at the first one that we have here. You got to evaluate the integral 3x squared sine x cubed dx. So again, you look at the x cubed right here, and you see here you have a 3x squared. That's the derivative of x to the third. So this is one of basically this format up here. Now, if this 3 wasn't there, you could still do the setup. It's still going to work as long as you have a constant there. Now, if there's another function of x, and that's a different story. But in this case, we're going to let u equal to x cubed. Differential both sides. This will be du is equal to 3x squared. And then you just, again, the object here, we're still using a u substitution, is to rewrite this so it's a function of u. Everything is involving u. You can have some constants, but you don't want x or dx in there. So, write this as integral of, okay, x cubed, or I should say, sine, and then we're just going to make the substitutions. X cubed can be replaced by u, so this is just u. And then 3x squared dx, if you look at this product right there, 3x squared dx, I have it right here, is du. And now this should be easy to integrate. In some cases, the more advanced problems, you might have to do with some other kind of substitution, but the idea is to simplify the integral. So now we just simply have to know the antiderivative of sine, which is minus cosine. And we're integrating here with respect to u, so this will be u. And you're always going to have your constant of integration when you're dealing with an indefinite integral. And then once you've integrated with respect to u, the last step is always to go back and replace the u by what it represents, and this is x cubed. So we're going to give the answer in terms of the original variable. So this will be minus cosine of x cubed plus constant of integration. And this is your answer. And again, in most cases, you can easily take the derivative of your answer, and you should get your integrand function right over here. So you can see that if I take the derivative of cosine of x cubed using your chain rule, this will be minus sine, but then this negative makes it positive sine. Okay, so I get sine of x cubed. And then you always multiply by, using your chain rule, multiply by the derivative of this function here, which represents your g of x function, and you get the 3x squared. And of course the derivative of a constant is always 0. So this is your check. Now I want to point out to you that sometimes it's a little bit harder to take the derivative and get the integrand function depending on the type of substitution you used. It can still be done, but in some cases it's going to take you longer to check than it would to solve the problem this way. Okay, so just keep in mind that it doesn't always work out this easily where you can just take the derivative and get your integrand function without doing some kind of algebraic manipulation, but you can check it. Okay, let's go to the next one here. And I want the integral of secant of 3x plus 1, tangent of 3x plus 1. Okay? So we know that the derivative of secant x, that's one of your standard formulas that I pointed out at the beginning of the video, is secant x times tangent x. So the derivative of secant x is secant x tangent x. Of course, the antiderivative of secant x tangent x is secant x. Okay, so you can see this is very similar here, except instead of an x, it's got 3x plus 1, 3x plus 1. So in this case, to make it easier, we'll use a u substitution. And you can see the obvious thing to do here, if this were an x, it would be very simple. So let's try to write it in that form, except we're going to use u. So here's my substitution. We'll let u equal to 3x plus 1. Then du, or the differential then, will be 3 times dx. Okay? So this then will be the integral of secant. Now we make the substitution. Okay, 3x plus 1 will be u. Next one, tangent. Again, 3x plus 1 is u, so this will be u. Now the only thing we have to do is replace the dx. Okay, so from this right here, solving for dx, I get dx is equal to du over 3. Okay. Now, if you had other constants, this would be pretty much a setup, except you have the constant there divided by 3. So in this case, replacing the dx by du over 3, and I'll just put that in front. It says 1/3. Okay, so now it's pretty straightforward. It's just the antiderivative of secant u tangent u with respect to u. So this is just going to be secant So this will be secant u plus a constant. And then just simply replace the u by 3x plus 1. Okay, now let's give the answer in terms of the original variable. So this will be secant 3x plus 1. Again, plus your constant of integration. Okay, this is your answer right here. Okay, so these are very similar to the ones in the previous couple of videos, except in this case you need to know your formulas for integrating or taking derivatives also of the trigonometric functions. Now let's clear this. Move on to the next one. Okay, so this one you look at the integral. The integrand has sine squared x cosine x. Okay. So what substitution would we use here? Well, see, we have u could equal to sine x, possibly u could equal to cosine of x, okay? But again, to get in this format right here and make it more easy to solve, u equal to sine of x, because look, if u is equal to sine of x, then when you take the differential on both sides, we get du over here. The derivative of sine is cosine, and then of course you have your dx. And you look at this, and there you have cosine x dx, okay? So again, it's kind of like you have f of g of x, and then the derivative of g of x is g prime. That would be this right here, okay? So this would be then simply set this equal to the integral of, okay, u is sine x. So when I have this sine squared, I would just put a u, and then of course you're squaring it. And then the cosine x dx, that's just going to be du. This then is equal to, then we just integrate with respect to u. Okay, basic polynomial here, one term. So add 1 to the exponent, get 3, divide, you get 3 down here, and then plus your constant of integration. And then once you do the integration with respect to u, your last step, as always, is simply to go back to the original variable. So u is sine of x, so I'll put sine of x quantity squared, okay? Or I could put it right here in this position right here. You don't want to put it on the x, okay? Because that's not the same thing, okay? And then this is divided by 3 plus, and this is the 3 here also. Okay, so it's sine x to the third over 3. Again, I want to point out to you that if you have sine x or any trig function, whatever, with some power, let's say in this case it's cubed, this would be the same thing as could put the cube here of x, but that does not equal to sine x. And put the cube there. Those are not the same thing, okay? So you don't want to do this. You don't want to do this or that. Okay, I'll clear this. And then the last one that I have here in this video, again, pretty straightforward. You have x cosine x squared minus 3 dx. This one should be fairly obvious. You see the derivative of x squared is 2x. You have an x there, but that's okay. Okay. Doesn't matter what other constant you have, this procedure is going to work, because if I let u equal to x squared minus 3, differential will give me then 2x dx. And then solving for x, or in this case, I'm solving for, doesn't really matter how you do it here, but here I solved for x dx. Okay, so by dividing both sides by 2 here. Okay, so divide this like this. This cancels out. So x dx is du over 2. So using that substitution, all I'm doing here is saying this is the antiderivative. Okay, the x and the dx are here. They go together, and I'm replacing that by du over 2. And I'm simply going to put the 1/2 out in front. And then this would be cosine of u. Okay. Now I could have just I could have done this also. I could have just said let's say dx is equal to du over 2x. Again, plug it in that way, the x's will cancel out, I still get the 1/2. Okay, so it doesn't really matter how you do this setup here, as long as you rewrite this so this expression, this integral and integrand, are all in terms of u and not x. Okay, so then here you go, this is 1/2. And we simply take the antiderivative of cosine, which is sine of u. And then I put my constant of integration over here. Now notice I have the 1/2 right here, so when I integrate, I actually get cosine of or sine of u plus a constant. So c is multiplied by 1/2, but 1/2 times c is still a constant. So I add the constant at the end over here. Okay, I don't want to put 1/2 c. It's still the same answer. I just put c here. So this is 1/2, and then sine, and then go back to the original variable. U is x squared minus 3 plus the constant of integration. So this is your answer. Okay, so that concludes the video. Hope this helps you out, and we'll see you next time. Thanks for watching.